How's it going, YouTube? This is Alex. Welcome to part 3 of our tutorial series, Unity with Node.js Multiplayer. We're going to be doing movement today. You're going to start seeing after this video a little quite shorter videos as we get into more nitty-gritty topics. That way we don't have a bunch of topics rolled into one video, but more one topic that gets talked over throughout the whole video. I'm just going to show you right off the bat what we had going last time. So I have my node server here, and I'm going to say node index.js, and we're going to see that it connects. Server has started, and we're going to start the tutorial. Now, if you did the homework from the last video, I'm starting based on where I just ended the video, so if you didn't do the little challenge part, it's okay because we're going to be going over that anyways. So if I go back to the server now, you'll see that the connection has been made. And then on our client, we get a game object that has a 0 transform, and its name is just server ID and then just a random hex code value that we assign via the server for their name. This could be that if you want the player to type in their name, maybe you make a .io type game that gets hosted on the web, and people can just type in whatever name they want. This will give you a unique name, and it'll be a lot better. So I'm just going to close this all out. So we're going to work with the server first. So in order to handle, we got all this stuff. In order to handle positional data, we have to make a new command. Okay, so we have commands right now for connection and disconnect. So I'm going to make one right here, and we're going to say positional data from client. We're going to say socket.on, so we're making an event, and not .on event, and we're going to say update position. Okay. Now these names from here on out, like I was saying in the first video, a couple of the names, connection and then like disconnect and stuff, they tend to be like pretty generic names, like this is what it is. From here on out, these are just custom names that I did. So if you want to do chat or something, you can follow a very similar path to what I'm doing now in order to do chat commands. Okay, so we're going to take in a parameter because we're going to pass in some data. So think of the client is going to be sending us its positional data, and that's going to come through as data. And then we're going to retrieve that data, put it into our player object, and then broadcast to everybody else. Okay, so in order to do that, our player object needs to store a position. And in order to store a position, we need to actually make a vector2 class. So if you head over to your classes here and just right click on classes and click new file, I'm going to type in vector2.js. Okay, and that's going to open there. And now we're going to make another module export. So we're going to say module exports is equal to class vector2. Now I'm going to fill out a bunch of things that we probably won't use this video, but they'll come handy later down the road, and they're just standard vector2 operations that you would want to do for anything game development, software, and all that jazz. So just like before, we're going to have a constructor. We're going to default some parameters of x and y just to 0, just in case. And then we're going to make some values inside here of x. We're going to assign it to x, and then we're going to say this.y and assign it to y. So vector2, 2 stands for 2 properties. We got x and y. If you are doing 3D or would like to transition this to 3D, just add another field. Pretty simple. And even the functions we're going to do now, you can just add another field, and you should be good to go. So the first one we're going to do is magnitude. It just shows the length of the vector itself. And this is done using a square root operation. So the math library is built in, by the way. You don't have to import that, but just know that if you don't understand this math, you can go look it up, and there's a lot of tutorials on how to do vector math. You'll notice when we get further in tutorials that we'll start using these functions, so just kind of understanding what they do becomes quite handy. So the first thing we're going to do is this math is basically x squared plus y squared, and that's the square root of it. So we're going to say this dot x times this dot x, and then we're going to add this dot y times this dot y, because there's not really an exponent function, but an exponent power of 2 is just itself times itself, right? And then so it's x times x plus y times y, and then we're going to square root that, and that's your magnitude. The next thing that's really handy is a normalized function. So a normalized function will take your vector and it'll put each x and y between 0 and 1. So we're going to say vector mag. So in order to do that, we need the magnitude, and we're going to say this dot magnitude. Just like before, if we're ever calling a function inside of itself, we have to make sure we say this. I can't just call magnitude. We have to use the this dot magnitude, and then we're going to return a new. This is going to be weird because we're inside of a vector of itself. We're going to return a new vector of this dot x divided by the magnitude. So if we had a magnitude, for example, of 5, and our x value was 5, that would give you 1. If the y then was 2.5 and the magnitude was 5, then it would give you like a 0.5. And that's how you get your normalized value. And these are handy for you when you're doing things for directional. So for example, when we get into aiming, you're going to want to know, based on the position of the player and the position of the mouse, what our direction is. Okay, so we're going to do that. So that is grabbing the magnitude and then dividing the x and the y by the magnitude to come out with a vector of 0 to 1. Okay. The last handy thing that I like to use is a distance. And it's going to take in a vector. So by doing this tells the class that what we're going to pass into it is a type of vector 2. So a distance calculation is we're going to grab the direction. We're going to say that's a new vector 2. That'll just assign it to zeros, right, in our constructor. We're going to say direction, if I could spell, direction.x is equal to other vector.x minus this.x. Okay, so we're defining basically the distance between two vectors, right? And we're going to take the one coming in and we're going to minus it from ours. And we're going to do that for each field. So like I said, if you want to make a vector 3, you do a direction.z as well. Okay? Okay, so that's all nice and handy. And then what we're going to do is, now that we have this nice vector, this vector is a product between two vectors, right? And we need to know the distance. So the best way to know the distance is to, like I said, grab the magnitude. The magnitude will tell you the length of the line. So we're going to say direction.magnitude. So if I was to draw this out, we had a vector at problems, for example, and a vector at vector 2. And those two positions get minus together, and it'll result in this line here, okay, this imaginary line. And then because if we grab the magnitude, it'll tell us the length of the line, which is also the distance. Cool. And the last thing we're going to output is just a handy console output, and this just helps outputting the vector itself. So we're going to say return. We're going to do this. And we're going to just do the y. So this will look like, in curly braces, the x comma y, right? I just put the comma. There we go. Say comma, and then we'll say this dot y. I'll put that brace. Okay. So it'll be just like a open parenthesis x comma y closing parenthesis. Okay. So now that we have vector 2, this is all we're going to set up for now. We're going to head back to player, and we're going to import that class. So just like short ID, we're going to go vector 2, and it's going to be require. And instead of it being part of the normal library, we're going to say dot slash. So we're going to go to this folder. We're going to basically go out of this folder to classes, and then we're going to say vector2.js. Cool. So that means now we can use vector 2s inside this class. So we're going to say this dot position is equal to a new vector 2. Cool. So now this position right off the bat will be at 0, 0. Don't worry about it for now. If you do need to instantiate like a spawn point or something, that's fine. You can always set it to that spawn point. But for data right off the bat, you do want to clear it to a 0, 0, which is really handy. Okay. So now that we have that information where the player can hold a position, the vector2 can hold a position, let's assume, even though we haven't worked on the client yet, that we have sent the positional data of x and y correctly. Okay? So what we're going to do is we're going to grab player, and if you remember that from player from the last tutorial, we save that player reference there so we can access it. We're going to say player.position because we just added it. We'll say .x, and we're going to say the data has also a positional vector inside of it with an x as well. Okay, and like I was saying before, if you want to do 3, I'm just going to do 2 right now. The x and the y, because I'm doing 2D, but if you do 3D, you can just add a z component. Okay, and the last thing we need to do is like we did here, where we're telling everybody else we've spawned, we're going to say socket dot broadcast dot broadcast dot broadcast dot emit. And this gets a little wonky, and you could technically rename this like update position, like updating position or something. I like to use this as the same name. So this is going to get called on our client. This is going to get like invoked on our client from somewhere, and then this is going to come to our client, but in like a different location. So if you do need to name this differently, that's up to you. But I like to keep these all tied together under the same name, so they're all updating position. And for now, we're going to pass in player. And something like I was saying before, if you wanted to optimize, we could pass an object called D for data, and we could pass in positional data of x is equal to player.position.x. And then we could do that. We could say that, well, we'll need the ID, for example, and we could say the ID was there. And you could make a nice formulated response that's only that data, because as you build the player, we're going to have a ton of stuff. For now, we're just going to be sending the player, so you don't need to worry about that. And that'll be an optimization thing that we can do later on. Okay, so we have made a new event. So after the player connects, we made a new event called update position. This will bring us some data from the player, which would be its positional data for the player. We're going to assign it to the player object, the positional data, and then we're going to emit to everybody else our new data, okay, our new positional data. All right, so we're going to head over to Unity. So this is where the chunk of the tutorial is going to go, okay? And we have to make a bunch of stuff. There we go. Sorry, I was just bringing up my my reference folder here. Okay, so the first thing we're going to do is we're going to make inside of code a player folder. And we're going to add inside here, we're going to add a script called player manager. And make sure that's all one word, because all your classes should be all one word. So make sure that is there. Okay. So in networking right now, we just have a networking client. Okay. And this is all handy dandy. And inside here right now, we're just creating a game object. And what we're going to want to do is we're going to actually want to make a prefab. So just right click, hit create empty, and we're going to rename this to player-prefab. Okay. If your transform is like this, where it's just random numbers, make sure you hit reset and everything's all zeroed out. Very handy. Okay. We're then going to right click on assets. We're going to hit create folder, and we're going to make a prefab folder. Okay. And you're going to just drag player prefab in here. Okay, so it should go blue when it makes a player prefab. So if you go into code networking and double click network client either here or the class itself over here, we're going to launch Visual Studio. Loading project. Okay. And we're going to add a couple of things, okay? So the first thing we're going to add, and I have my reference stuff here, yep. It's much faster if I do the project first and then do the other part. Okay, so we need reference to that player prefab in order to instantiate it. So we're going to say private game object player prefab. Okay. And we're going to, we'll fix this up in a minute. We have to add a couple other classes, then we can kind of do some stuff. So a couple things missing from here that we're going to add is we're going to add a static variable. So the reason why it's static is because I want reference to this variable no matter where I am, and this is mainly to do with network identities, and I'm going to explain network identities right after this. So this is, if you've never seen this before, this is just a public property, and I'm kind of giving you, telling C# how this property can be accessed. Okay, so what I'm saying is that I have a static string called client ID. So anybody can import my namespace project networking and go to project and then do network client.client ID, and I should get the same value. There's only, even if I had 3 of these network clients, I would only ever have 1 client ID. Okay. What I'm saying is that you can publicly get this variable, but you can't change it, and it can only be changed within this class, okay? And that's really handy for avoiding scripts that people might write for mods and stuff, or just being safe, right? We just want to be safe, make sure that no one else can play around with their client ID. It's coming straight from the server, and it's being assigned, and only using it that way. Okay, so client ID. So I remember we made a function called register. So if we come down here to register, we're going to replace string ID with client ID. You will get an error here, and we have to replace ID here as well with client ID. And I'm just going to remove the space functionality-wise. Okay, so let's go back to Unity, and we're going to talk about a little bit of networking. Okay, so we have our player prefab. And our player needs to be able to transmit its data to the server. Okay, so we had our ID tag and we were saving it to just the name of the game object. We need a way to store that tag, and then we need a way to have that tag be able to tell other components on the player if this is our player or if this is another player on the server. So the best way to do that, it's used in UNet, it's used in a couple other things. They call it a network identity, and we're going to make our own here in a minute. And basically all it is it's going to have that little name that comes from the server, the little hex code, and it's basically going to tell all our other components that want to know anything about networking if we're controlling it. Okay, so the concept between server authoritative is that your client controls your client's stuff, and the server controls server stuff, okay? And it relays information from other clients to each other so they can be updated, but you can't change anything for another client, okay? So client 2 can't have its positional data changed on client 1, okay? And the best way to do that is by having a network identity. So we're going to go into networking. We're going to create a new networking script. We're going to call this network identity. Okay, that's going to load up here in a second. The next thing that we're going to create, just right off the bat, is we're also going to create a network transform. And the reason why we need the network transform is because while the identity tells us who we are and who controls what, the transform tells the server our transform data, okay? So the best way to do, I found with networking, is to break it out into little steps. Don't just have one class that does everything networking, like shooting and positional and aiming, all that. Let each class handle its own little thing, okay? So we're gonna go into network transform. We're just gonna say project.networking. I'm gonna bring up network identity. We're gonna say project.networking. Okay. All right, so we're going to do a couple helpful things. We're going to say header. We're going to say helpful values. So the reason why I'm doing these helpful values is that this will allow us to click on an object and it'll be able to tell you the ID of the object without us changing it, okay? And the way we're going to do that is using attributes. So these right here that I'm putting on are attributes, and they affect the property that's below it. So I'm going to do string ID. So, and then we're going to do one more, and we're going to say private bool is controlling. And for anybody familiar with Unity, theoretically these could get changed or something, or they look like they can be edited inside the editor, and somebody might make that mistake. So we're going to actually create our own attribute, and it's going to be called the grayed out attribute. So if you go into Unity, utility, and then you go to create, we're going to create a folder. We're going to create attributes. And we're going to go to create, code, namespace. We're going to call it gray out. Okay. So what this will do is inside the class here, see how these are all editable? Picture it just being grayed out where it's only readable. And that's basically what that is. Okay, so in order to do attributes, so we're going to say project utility attributes, and we're going to inherit from property attribute. Okay. We're going to close this, and we're going to do a little if thing. So this if statement tells the compiler if we're the Unity editor, okay? So if we're not in the Unity editor, so if we're making a build, for example, this code inside this bracket doesn't get executed, okay? It won't get compiled. So if you've ever ran into issues where things, you're getting errors when compiling, or you're not able to access like gizmos and handles and all that jazz, then it's because you don't have it surrounded in the proper tags. Okay, so we're going to say type of gray out. Okay, cool. And this is going to be a public class gray out drawer. So what we're doing is we're making a property drawer. And it's just telling the inspector how we draw this on the screen. And I'm going to bring in the engine as well, and then we also have to surround the namespace, because when Unity compiles builds, it doesn't bring the Unity editor DLL with it. So you'll get errors on that part. And what we're going to do is there's a couple overrides for this, so we're going to say, where is it? The property height. And we're going to return editor GUI dot get property height of property label, and then we're going to set it to include its children. Okay. This is basically what it's saying is that it goes through every property that is here. We don't have anything. That's the funny part. But we'll have a single thing. We'll have like a string or something. And it's going to go through the string, and it's going to say, okay, it's the string or the list or something. And it'll go through every property, and it'll make sure that it grabs the proper height for it. So then what we're going to do is we're going to go to public override, and we're going to override the onGUI. And there's a nice command called enabled false. This is how we make it gray. We're going to say editor GUI.property field. We're going to say position property label, and then true. And it's okay if you don't really understand this. This is more of an advanced technique. You'll see the benefits, I guess. So we're gonna close that out. So now if I go into here and I click on the player prefab, and I go into network identity. So you're gonna see two, right? You're gonna see this one's from UNet, and then we have ours. You're gonna see these, right? And I can type in and click and stuff, and like you shouldn't be able to do that, okay? So if I go back into network identity, and under here I do gray out, we bring in the namespace for attribute, okay? And then we save, and I come back in now. When it goes, you're gonna see it's grayed out, and I can't touch it. Okay, and the beauty of this is there's gonna be, say you have like 50 objects that are getting ran by the server, by you, by other clients, right? And you go to click on one, it'll tell you the ID, and it'll tell you if you're controlling it right away. Like it'll give you that snapshot, if it's you, if it's another client, if it's an enemy, like all that. So that's why I'm showing it. That's why I gray it out so you can't edit it, but it helps with debugging in the future. So we're going to go back to network identity, and we're going to add a couple more things. So we're going to say private socket IO socket component. So I'm going to erase this, and the reason why I do that is it's a lot faster than remembering the class I need to follow the namespace and then remove it and then bring it in properly. Okay, up here. And we're going to say socket. And this is so we can send events, or we can have other components ask network identity for this variable, and then it can send events, right? So our network transform, for example, is going to ask this for the socket so it can send the update position. So we're going to change this to awake. And we're going to say is controlling right away is just false. As soon as you execute code, just set it to false, please. We're going to rename this to set controller ID. And this will take in the ID. And this will get set. So this is how we're going to set the ID. It's only going to happen once, and it's happening when we're creating it. Is controlling is going to be equal to network client, not client ID. So this is what I was talking about with a static variable. I can grab this without knowing the class because it's static. And we'll say if it is the ID, then set to true, else set it to false. And if this is the first time seeing an inline style function like this, just basically think of this as if I wrote this like an if statement, okay? If this is true, we're gonna do this set of code, else I would do this set of code, okay? So instead of writing an if else, we can kind of do it in one line, and it kind of cleans it up a bit. So we're gonna say check incoming ID versus the one we have saved from the server. Okay. So now we need to set the socket reference. So like I was saying before, we have this variable for the socket. Now, network identity doesn't create the socket, but the network client does. So we're going to say this is a software component, socket, and we'll just set our local version of socket to the one incoming. Some other handy things we might need from this class are knowing the ID. So we'll say public string get ID. We'll just return ID for them. And then one of the biggest handy ones is are we controlling? So is controlling, and we'll return is controlling. So after we have laid down the basics for all this stuff, writing in new components like aiming and stuff is going to be a lot less work, which is why like movement at the start is going to be such a long video compared to everything else. Okay, so the other thing we want to do is be able to get the socket, right? So if network transform wants to get the socket, for example, to send a message, we can grab it from our network identity. Okay, so network identity is done. Basically, it is controlling an ID, and that's all it kind of really does for us. But it is quite handy. Now, what we are going to do is we're going to start setting up the network transform. So I'm going to do a thing called require component. So what this does is in Unity, if you were to add this component before the network identity, it's going to add a network identity for you. Okay? Just in case. Just because we need to use it and other people might need to use it. So if you already have it on there, it won't add it. Okay, so we're going to make a variable, and we're going to also say this one's grayed out. We're going to say position. We're going to say old position. So this is more just for debugging purposes. We'll also have a variable for the network identity. And we're also going to have a variable called player. And we're going to make that class in a second. So we'll just leave it as an error for now. And what I like to do is I like to send, if you're standing still, for example, then the old position won't be different from the new. So I like to have a counter that if you're standing still, it'll update every half a second or something to the server, so everybody's getting the latest information. So we're going to have network identity, and it's going to be equal to get component network identity, and we can guarantee that's coming in because, like we said, it's requiring it. Old position will be equal to transform.position. Player is going to be equal to new player. So there we go. All right, so we're going to make this class. So this class is mainly just data. So if you come up to the top of network client, if you're in Visual Studio, you can click the curly brace here, and then it'll highlight the ending curly brace. I like to use that. And we're going to say this is a serializable class. This is not going to show for you. This is in the system namespace, so you can either do system.serializable or you can try typing in the word. I'm going to bring in the namespace. I'm going to say public class player. And the reason why I'm saying it's serializable is so I can have this data sent over sockets. I can have this data inside the inspector, and all it is holding data. Okay, you could do a struct theoretically. I'm just going to do it as a class. It's a lot easier. So we're going to say inside a player, there's a player, and then there's going to be a position, right? So if you remember seeing, oops. So if you remember seeing on the server, we have data.position.x, right? And then the ID is also coming in. So we don't have this class either. So we're going to do the same thing. We're going to say serializable public class position. And these are basically just, like I was saying, they're just data points for things sending over the network. Okay, and you can have a separate class. You can put it in this class. It's totally up to you. And that's going to show now. So now if I go back here, we should have all our errors fixed. And we're going to just set some things up by default. So you're going to be wondering why I have a reference to a player object. This has to do with recycling and just reusing. Instead of creating new memory for a new player object every time I move, I can just recycle the one that I always keep. And we're going to say this is equal to a new position. And then we're going to set the position just to 0, just to be safe. So everything is initialized, everything's set, everything's good to go. Okay. And then the last thing we're going to do is if the network identity is not controlling, so if we're not controlling this script, we're going to say enabled is equal to false. So we're going to turn off transform sending if we don't control the object, right? So that's what I meant by this being very handy in telling us that we control things, because then we can turn things off like cameras, or in this case, the script itself. So in the update, we're going to say if network identity is controlling. So you're going to be using this a lot throughout network coding, basically writing in, hey, am I actually controlling stuff? Like, should I do it? So if the old position is not equal to the transform position, then we can assume that they've moved. Okay? And if they've moved, we can set old position to transform position. We can reset our counter, and we'll go over the counter in a second. And then we can do send data. So we're just going to have a function down here called send data. Okay, and this is what actually will get sent over the network. So if the position is different than our current position, we're going to send data. Else, we're gonna start counting. So if you're standing still, I want to be able to count, and the way we're going to do that is using the time.delta class. And we're going to say still counter is greater than equal to 1. So every 1 second. You don't need to do it a lot. Like you don't need to be hammering the network with data, right? Every 1 second is sufficient, at least in most cases. So if we're greater than 1 second, we're going to reset the counter back to 0, and then we're going to send the data again. So it'll just send that same old position, but it's telling the server, hey, I'm still here. This is my position, don't worry. Okay, so we now know that a player needs to send information to the server about its position. So the way we're going to do that is we're going to say player.position. So remember, that's just our player object, our container of data. And we're going to say math.round. And the reason why we're going to be rounding is because you may get positional data that's like 10 decimal points. You don't need that, okay? We're only going to round to 3. You just don't need that. So we're going to round. So we're going to say transform.position.x. And we're going to times this by 1,000 float, and then we're going to divide by 1,000 to get our decimal place, okay? So this will give us like a 3-point decimal place, and I'm just going to highlight. I'm going to copy because it's a lot to rewrite again, and I'm going to continue writing. Okay, cool. So now we made the player object. We've made it with its positional data. We're going to send this to the server. And the way we're going to do that is at network identity. Remember, we had a socket reference, so we're going to grab the socket, and it works just like the server where we have an emit. Okay, and this is our update position. Make sure you spell it the same, right? We're using a lowercase followed by an uppercase. And this is where it gets tricky. So using this socket IO library, we have to wrap things in what they call a JSON object. I know Unity has a built-in JSON utility, and that thing is handy, but in order to work with this socket IO component, we have to use their stuff. So we're going to say new JSON object. And the way the JSON object works is it wants, a JSON string, okay? And the easiest way to do that is using the built-in JSON utility, where we can go to JSON and we can pass it in an object of data. And that's why we're going to pass in player. And that's why we had it serializable, and that's why we had it just data. It's so we can convert it to JSON. So this will convert it to our nice JSON formatted string. And then we'll convert it to the little object that they need to send over the socket IO. Okay. Let's go to network client. So a couple things we got to add in network client. So before, when we were instantiating, we were creating an object ourselves. We now have a player prefab that we want to instantiate on the network. Holding game objects in a dictionary is kind of slow. Okay, like it's a lot of data to hold. It doesn't need to hold that much. All we need to hold is data about this player object, which happens to be the network identity, right? Basically, we just need to know its ID. So we're going to change game object to network identity. Okay, we're going to get a little error down here and make sure you change this reference to it. Okay, and we're going to go all the way down to our spawn, and we're going to fix these errors as well. So we're going to erase this line, and we're going to change it with a proper instantiate. Okay, if I could spell instantiate. And the way instantiate works is it wants the game objects to instantiate, so player prefab. And then if you do a comma, you can throw it in so right now below we're setting the parent. We can actually do this in that same line. So we're going to say network container. Because we're setting the parent there, we can get rid of this. And we're going to we actually got rid of how we named it. So we're going to say go.name is equal to string.format. And we're going to format how we want this name. So we're going to say just basic string, and we're going to say, not data, that's my bad. We're going to say ID. And we're going to make it look like player. So if you never used this before, basically the way it works is you have a string, and then you use curly braces with the index number for every variable that's after, and you just keep comma, like comma, and then next variable, comma, next variable. Okay. The next thing we're going to do is we're going to grab reference to the network identity. So everything network that we're going to spawn is going to have a network identity. We can assume that. We're going to say go.getComponent, and we're going to grab its network identity. If I could spell, from that server. And we have a couple things from the functions that we have to set. So we have to say, we have to set the controller ID. So we're going to set that to ID. And then we're also going to set the socket reference. And that's just set to here, and that'll be able to get its socket reference. Okay, cool. And then because we now changed the dictionary, we have to assign it to the network identity. If you come down to destroying, we can just say server objects.network identity, and then because it's attached, this will return to you the network identity, which is a script. We can say .gameObject lowercase, and that'll give its game object that it was looking for to destroy. Okay. And then the last thing we can add now is, so now we're able to send update, right? It'll come to this, it'll do this, and then now it's going to broadcast. We have no way to handle messages coming in from the server about update position. So just like we did with disconnect and spawn and register and all that jazz, we're going to say on update position. So this is mostly going to be positional data that's coming from other player objects, enemies, anything controlled by the server, or nothing that's controlled by you. Okay. And that's going to be an arrow function like we had before. And we're going to say string ID. So it's going to pass us through the string ID. And it's going to pass us a float x, which is going to be e.data. Inside there is going to be positional. And then inside that is going to be x with the lowercase x. And then the JSON object has it has a couple things. So if you have booleans or floats or anything, you can do dot. It does it weird because it's very cheap, or it doesn't say dot float. It's like dot f or dot n, right? Like, so it's gonna be a dot f for a float, and we're gonna do the same thing for y. Make sure when you do this copy, you do change all the instances of x to y, because that happens quite a bit. Okay, cool. And so what we're going to do is we're going to grab the network identity. So what we're going to do is we're going to search the dictionary for the ID that we got. So we're going to say server objects at ID. And that's going to give us that script of that object that we're talking about. And we're going to say it's transform.position is equal to a new vector3 x y, and then 0 for z. Cool. So now the network transform will send to the server, and then anybody who gets a message will come through here, we'll find it, and it'll go all there. Okay. Now we did a lot, and we need to adjust some things, and hopefully it should work. Fingers crossed. Okay, so if you go into the player prefab, we have a network identity. We're going to attach in a network transform. And we're just going to hit apply. So the apply will apply it to that prefab. Okay. We're going to click on coding network, and you're going to attach the prefab from the assets, not the local one, because we're going to delete that in a second. You're going to attach that there. Make sure you save. We're going to delete this one from the scene, and we're going to hit save as well. And we should be able to. So if I go into the server and I say node index.js, it's going to start up. And we should be able to run this. And we get a player, and it's going to say that's the ID, and it says we are indeed controlling it, as well as the network transform. That's all fine and dandy. We don't really have anything on the screen showing. Like that's not too fun. So we're going to drag the prefab back in, or right click on the prefab. We're going to go to sprite, and we're just going to attach the knob component that comes built in. If you want to go make your own sprite, like you can do that. Just basically make them children. I'm going to just rename this to sprite, and then like I did before, I'm going to hit apply. Okay, delete that, save. I'm going to restart again. So now if I come into here, I'm going to spawn. You're going to see our little dot spawn. Yay! Now we're not moving. So I had you create the player manager class a while ago. So we're now going to open that. And we're going to start filling this out. So the way the player manager is going to work, we're going to set this to a new namespace called player. Is we're basically going to handle just kind of all commands like movement and aiming and stuff in here. If you want to spread this out even more, you're free to do that. Just for our tutorial sake, I'm going to keep everything kind of neat and packed here. So the first thing we're going to do is we're going to have a speed. I'm just going to set this to 4. You can set whatever, like I said before, you can set it to whatever you like. And I like to do, when I do class references, I like to keep it away from my data for the class. So the reason I'm going to have the network identity. Boop. Network identity, and I'm going to bring in the namespace. And make sure you bring in my namespace, or our namespace for the project called project.networking, and not the actual unit one. Like make sure that you do check that. And the first thing we're going to do is we're going to get rid of the start. We don't need the start here. We're going to say in update, we're going to say if network identity dot is controlling. We're going to make a function for checking movement. Cool. We're going to say private void check movement. And we're going to just do a very simplistic, we're going to grab the axes from Unity. So if you've never used the axes before in your project settings, they have some standard Unity ones for doing button layouts, and one of them is the axes for WASD and map to the arrow keys as well, and they're called horizontal and vertical. And that's a semicolon. We're just going to store those right now to temporary variables. We're going to say vertical, vertical. And just for today's lesson, we're going to say transform.position is plus equal to new vector3, the horizontal data, the vertical data, 0, and then we're going to times that by speed, right? Otherwise, it's going to be going, this is raw data between -1 and 1. So your vector is basically normalized. And so we're going to times that by speed so we can go fast. And then you always want to, whenever you're dealing with movement and stuff, you always want to make sure you use time.delta time so it's smooth over all the frames, and you're always moving the correct increments that you need to go. Okay, cool. So if you close that, you come back to the player prefab on the left, and we're going to wait for Unity to compile. Dun, 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 dun. We're going to add player manager to there, and it's looking for the network identity, so we're going to add that. We're going to hit save, and we're going to hit the start here. And if you know, so we are controlling it, right? So if I click on this, we are controlling it, and if I wasn't controlling it, we wouldn't be able to control it. Okay, that's all fine and dandy, but you actually want to see this work. So if I bring up another project, I actually have one over here. So if I come in, I'm going to come in and start my other project here. You're going to see a connection has been made, okay? And I'm just going to, off screen here, I'm going to move the dot over a little bit. We're going to start up our tutorial. And just like we were before, you're going to notice connection's been made. and we have 2 clients. And if I click on one, it's going to say this is the ID, and we are indeed controlling it. And if I go to the other player, you can see the network transform has now been off. Okay, and you remember we took the precaution in Player Manager to not handle movement if we don't control this. So if I come into here, I can control our dot and move around, and you'll see I'm not controlling the other dot, I'm not affecting the other dot, and it's just sitting there. If I go to my other screen, click on that, and I start moving around, you'll now see it's moving, going through the server, and getting updated on our side. And if you want to check some cool things out, so if I go over to here and I try to modify this, you'll notice, where does it go? It always goes back. Okay, so you can't affect anybody else. It's awesome. So we're going to end the tutorial there. I know that one's a very long one. The next ones are going to be they should be a lot shorter. We have laid down the groundwork for how input comes in, the network identity, and everything like that. And so they should be a lot shorter from now on. We're going to be doing aiming next in part 4 of the series. I'd like to make sure that you guys subscribe, give it a thumbs up, give it a comment. The comments make me keep making these videos. Okay, so keep going at it. And always have a good one, guys.